Welcome. Thank you very much for joining us. My name is Peter Nugent. I'm with AeroPM, and today I'm filling in for our GM, Adam Frizzell, who's just having a small operation. So I'd like to start by acknowledging the Ngunnawal and Ngambri peoples, who are the traditional custodians of the Canberra area, and pay respect to their elders past, present and emerging, and to all Australia's Indigenous people around the country. The role of the AeroPM Learning Together program is really about trying to give back to the defence community. Our team at AeroPM has an extensive background experience in a number of fields around acquisition primarily across each of our domains. We feel that this program can prepare CASG and defence industry as best as possible for the challenges that lay ahead, particularly in light of government's most recent announcements to plus up the overall capability. Our presenter today is Mr. Sean Noble, one of our esteemed senior consultants at AeroPM. Sean is a highly credentialed project director, portfolio manager, and experienced military commander with decades of Navy logistics experience. In more recent times, he has led the capability element responsible for planning and execution of Joint Command and Control. You may know that formally as JP 9111. And he's governed the project responsible for the implementation of the Defence Enterprise Resource Program as the Navy and Maritime domain expert. He holds a Master's of Business and separately a Master's of Management from the University of New South Wales, a swathe of logistics qualifications, and is a Fellow of the Chartered Institute of Logistics and Transport Australia. He is here today to share his experience so that we can learn about the unique challenges that beset Navy logistics. And I think you'd agree that there's unlikely to be a more qualified individual from whom we can learn together today. Please make Sean feel very welcome. Sean, over to you.
Thank you very much, Peter. I'll just get into it straight away. All right, so thanks for the introduction. I just want a quick overview of the presentation. I'll quickly talk about the project scope, then about naval shipping and how we go about extending their endurance. Then I've basically split it up into three areas, the prepared, deployed, and how we come back. And I've left some extra time for questions. Just on the questions or points that you'd like clarified, I'm happy for you to interrupt me during the presentation and we'll stop and we'll talk a bit about that, or you can save stuff for the end. So this presentation is official. It's not classified and I won't be discussing any commercially sensitive or current contractual issues other than to talk about the type of contracts we have as opposed to the current contract holders, or in fact, there's one of them in the moment that's actually under a tender process. I'm then going to talk about the challenges in naval operations and how logistics is a key to actually projecting power in the maritime domain. And the last little plug is that Navy logistics is the business of the Navy. Operations, then the logistic challenges. So first and foremost, the Navy operates in a corrosive environment. So everything we do is subject to the sea, whether that be through the action of the sea itself or through corrosion. So the materials that we use and how we get it and move it around, we have to factor that in. The Navy operates as isolated. So the current deployment cycle for the longer deployments are a 9-month period. So we must keep that platform running for the whole 9 months. So the trick there is to try and work out what you're going to take and organising your replenishments accordingly. A ship is its own little city, a couple of hundred people on board. It makes its own water and its power and has a sustained life. It runs 24/7. The key point with that, and as far as information systems and the like that go to support that, is that there is no cellular, no internet. So having web-based tools is not effective. So more onto that, A ship's job is to remain undetected. Ships are big, so yes, the ocean is bigger, but the way they're normally detected is by the emissions that the ship makes. So to be undetected, you've got to kind of like make sure, limit your emissions. The ship has a job to do, is to control space and project power. So we need to be able to enable all of that. So everything has to be kept going. The ship's also responsible for its own maintenance and any underway repairs. So we need to be able to facilitate that. And lastly, the ship's not just about warfare. They have multiple other roles, including diplomatic, law enforcement, humanitarian assistance. It is a surveillance platform, and we can do denial of areas and other protection type activities. So that's what the ship does and where it works. So the challenges are how to make all of that happen, given those constraints. So the ships and submarines that we have are designed around the weapon systems, which, you know, saying that out loud, it's like, you know, it sounds pretty obvious, but most people, well, not most people. So a warship is not like a cruise ship. There is nothing luxurious about it. There is the close confines living that people have to do, because the people are fitted in around all the machinery and all the weapon systems. So that has its own challenges as well, with things like hygiene and cleaning. So the good example, I suppose, right now is the COVID cases that were on the cruise ships that came into town. That happens quite often on a ship, not COVID, but if someone gets a cold or a flu, it doesn't take too long before the entire crew gets infected. So you get that sort of retransmission purely by the close proximities that everyone is living in. Back to more the traditional logistics things and about how to extend a ship's endurance. The primary ways that ship's endurance is limited is firstly by the personnel, by the food consumed. Secondly, depending on the mission, obviously, and how much ammunition you're expending, the fuel that you get to use, and the equipment that needs to be maintained. So in the slide there, I've got 95% of 90 days. So that's when we work out what sparing to take on board. We do it on probability. So we look at the planned maintenance in any 90-day period, and then we'll stock the ship's storerooms at a 95% probability that we'll have the spares needed to conduct that planned maintenance. Obviously, that has it's augmented slightly by reality. Some of that planned maintenance will be of equipment that's too big to move by men, so we'll need specialist lifting equipment, and would be dangerous to move at sea. So that don't take that with us. Likewise, the sparing has to fit through doors and hatches. So if it's physically too large to fit through that, we won't take that either. Fuel, we'll get into razzing in a bit, but which is the preferred way of taking fuel short of a naval port where all those sort of things are alongside the wharf. Actually, I'll do that now. Do that now, just 2 seconds. So I've got a small 1-minute video I'm going to play of 2 ships conducting a RAS and a little bit of an introduction from one of my former ships. So I'll just do that now. Bear with me 2 seconds.
Replenishment at sea, or RAS, is when we come alongside another ship and we'll pass lines across so we can conduct refueling. We'll also often utilise helicopters to be able to transfer stores across. We'll take on anything from fuel for both the ship and the helicopter. We'll also take on fresh supplies, so things like food, frozen foods. We might take on machinery parts, other critical things to extend our deployment. Instead of the logistics of pulling into a port, which can take quite some hours, obviously a lot of liaising between different agencies, we're able to quickly and effectively get all those supplies we need on board and carry on and continue our mission. We've RASed with a number of different ships from different nations. Off the Australian station, that's something we probably wouldn't get the opportunity to do. So far we've RASed with some American ships, British ships, and a German ship.
So Sean, while that's being adjusted, can you tell us, are there ships that just don't have the compatibility to be able to conduct a RAS? Is that another consideration for a logistician about, you know, where things are in the area of operations and which two ships or multiple ships can RAS and those that can't?
Thanks for that question, Pete. Mostly it's to do with all of our allies. So we utilise similar sorts of equipment. So you would have seen the probe that went in. That's a 7-inch probe. So that's traditionally, DFM will come through the ships on that. The typical pumping rate is 680,000 litres an hour. So put that in perspective, that's a road tanker every 3 minutes. Those refueling rigs are made such that, you know, the ships can emergency break away. So, which obviously means we're pumping fuel at the rate of a road tanker every 3 minutes into the ocean. You know, so we need to get that stopped pretty quickly. But yes, we have standardized equipment so that we can do that with our partners. As you heard in that video, that actually RAS so far with 3 different nations on that particular deployment, which is not uncommon. The AORs, auxiliary oiler, is the term that, or the NATO classification of that type of ship that supplies that. The oiler is obviously the 2 sorts of fuel that we use, so which is usually JP5 and DFM, which is the marine grade diesel. That's common across most of NATO, as well as the Kiwis. That they also transfer stores, so that would come VERTREP, which is obviously the helicopter operations, to the flight decks. And we also do transfer of personnel. So right now, the limitations of transferring personnel via the winch is daylight only. That's an Australian limitation. We've talked about food, personnel, right? I think we've got. I just wanted to make sure that I've got the right. What I'm looking at is what you're. Yeah, I've just got the thumbs up. Thanks for that, Rashay. 6. So before and after contracts. So in the picture that you should be able to see at the moment, that's the marine engineering officer looking at the probes to make sure they have a good seal before they go ahead and start pumping. Obviously, we're all closet greenies and we don't want to put any unnecessary fuel into the ocean that we don't have to. So having those rigs come across, and then they literally ram it home so it clicks in, and then they have to check to make sure the seal's there before they actually start pumping. So traditionally on those rigs, you'll see the 7-inch pipe at the top, which is DFM. This one is actually configured, but it's not. You see, it's got 2 7-inch probes. So that would be fulfilling a larger ship, which Australia doesn't do. So that'd be doubling the flow of fuel. And there's a smaller pipe underneath it, which would be either water or JP5. So they all come to the same refueling point. Traditionally, Australia would only do 1 at a time, but the bigger ships like the cruisers will take multiple, which also brings into things like nuclear power. So, you know, you think if you have a nuclear warship, why would you need to take on fuel? Well, it's basically for the aircraft. So even an aircraft carrier will need to take on or have a supply ship with it to provide it with extra aviation fuel, depending on its rate of effort, noting that it's a carrier and it carries a bucket load of aviation fuel. So what I want to talk about in this particular slide is before we deploy. And so we have a whole bucket load of different contracts and agreements that we've set up around the world. The first being MLSAs, so the Mutual Logistics Support Arrangements, which is a contract between nations. So we have a host of them which are negotiated on how we exchange logistics support between different nations. So traditionally they're on an annual basis. So we will I'll pick on fuel. It's nice and easy. And the Americans, so we would take fuel from an American ship. We would give Americans fuel from our tankers. And at the end of the year, they add up and they send one another a bill. SONPAS, which is the current contract that's it's been led at the moment, Standing Officer Naval Port Agency Services. So that's basically all the alongside services that we would require at any port anywhere in the world that we would go to. We currently have we've broken the planet up into different areas, and we have different contracts or different agreements or standing offers for different regions. So currently there's a different region for Australian Station, the Pacific, Asia, and there's another one for the Middle East, which I help write. Those services include everything from browse to tugs to resupplying the ship with fuel. If we haven't been able to RAS, we'll take fuel by road tankers. And to put it in perspective, a ship might take 500 CZs, 500,000 litres of fuel when it comes alongside a port. At a road tanker, which is 30,000 litres per tanker, you're obviously going to take on 20 road tankers worth of fuel. That would take about 4 or 5 days of continuous 24 hours refueling, provided everything worked fine, to refuel the ship. As opposed to if you did it at sea with a RAS, you'd have the whole thing done and dusted in under an hour. So RASing is much more preferred way of taking on fuel. Or if you come alongside a military port where we have all of that, those facilities are embedded in the wharf. So the ship literally plugs into the wharf and can take its fuel that way. SONPAS pre-positioning. So even when you want to RAS, so you're going to take food or stores at sea, everything has to be pre-positioned. So a supply ship, an AOR, doesn't have necessarily a Coles, Woolworths sort of catalogue where you just pick what you want. You have to put all those provisions on board that ship before it sails. It will hold them in its cargo holds and it deliver it to you at a point in the ocean at a point in time. So to do, if you have a maintenance requirement, or as in a corrective maintenance requirement that you don't have the parts for and you're going to get them delivered at sea, it's not a quick process. You have to organise to have those parts delivered to where the logistics ship is. Has to clear customs quarantine in that host country. Then it has to come out to you for transfer at sea. So that could take anything up to 1 or 2 months, depending on which country you are and how awkward the customs and quarantine clearance is going to be. Which is why we engage agents, which is part of that SONPAS contract that we were talking about before, in order to have stuff expedited through those different countries' legal regimes to get on board a ship to get out to us at sea. Obviously, mail chases the ship around and we exchange out personnel. So typically we would prefer to do that at a port as opposed to having them come out via a logistics ship or a helicopter transfer at sea. Pre-positioning. So that's the before we go. Next is the RASing, what you saw before, and the way that moves. So in the, obviously that's delivering and receiving. So they're actually sending, on the photograph to the, or the image to the left of your screen, that's a flight deck team trying to hook up those pallets to the aircraft to take them over to supply or send back to another ship. On the right, you'll see 2 aircraft working behind the supplying ship and the receiving ship, who are also simultaneously conducting a RAS. So looking at the funnels on the supplying ship, that's a USNS ship. So that's a civilian manned grey warship. That's part of the American CLF, their civilianised logistic force that's providing both, in this case, looking at that rig that they have across, they're only providing fuel. But you see the 2 smaller hoses hanging underneath, which would be for either water and or JP5. and obviously several aircraft working the decks. So typically what would happen there, the CLF ship would have its own helicopter and the supplying ship would have its own helicopter. So the two helicopters would tag team across the back of the ships, delivering all the stores and sending over retro. So they drop all the air handling gear, and then ultimately, after it's all been unpacked, they send that back to the supplying ship, so that you don't end up with a bucket load of AHE. Port visits. So ultimately, a ship will come alongside a port somewhere, and that's usually predicated by what we call a log rec. So 72 hours before a ship would come alongside, they send off a standardized message to the agent ashore about all the different things they would need. So again, from berthing assistance through to what time they're going to be there, to what sort of repairs they would want, the stores we're expecting, what time we're going to leave, the state of the ship, so that if the host nation has any concerns that we don't have any viral outbreaks or any sick and injured people, or people we want to offload, or the equipment we want to offload, or the aircraft we want to offload, or the aircraft we want to unload, that's all contained in the log rec that goes off prior to our arrival. So that when we come alongside, it's all prepared, we can get going as quickly as possible. So in a perfect world, the only reason for the ship to actually go alongside is for logistics reasons. But that said, you think about the initial introduction that I gave about the different sorts of missions that a ship might have. So whether it be supporting Austrade or doing some community or nation building type activities, whether that be hosting a function or some humanitarian assistance, a whole bunch of different requirements for why we would come alongside. I have skipped something, I'm sorry. So a couple of the other things that are consideration that the logistics staff are responsible for is obviously diplomatic clearances. You can't send a foreign warship or an Australian warship into a foreign country without permission. That is actually an act of war. So having that organised beforehand, with which the Navy actually does at MAROPS. If we do send people back from different ports, they still need to have passports. So you have to get those passports stamped in and out, clearing customs and quarantine as required. The compassionate returns to Australia and the medevacs were also organised by the loggie on board. And when we're overseas, that is Air Force and JOC who would be authorising all of those. Some smaller ports, we would need to conduct our business in cash, which is very rare nowadays. Generally speaking, the agent would pay for everything that they can, unless it's, which is why we have that agency in place, so that the ships, back when I was a junior guy, would take a lot of cash with us and conduct business in cash. It's still there, just not done. Mortuary fares, CBRN, they're also the remnants of the loggie. So depending on where you're at, whether or not the ship has to be prepared to conduct CBRN type activities of protection, and everyone, accidents happen. So we need to be prepared for any fatal or tragic accidents. Repairable parts, we talked about. Food, sorry. During and when we RAS and how we go about feeding people, the fridges and freezers on board are of a unique size, which is to say they're too small. And so we pack those fridges and freezers so that we're optimizing how we actually literally eat into the fridge and freezers. So most ships will work on what we call a 6-week cyclic menu, so the menu that repeats itself every 6 weeks. And we have all the food embarked in day lots. So, you literally stack the freezer or the fridges such that you take the day's meals out at a given time, which maximizes storage efficiency, as well as keeping the variety of food that's available to the crew. Things like waste plans. are a huge issue. Australia, we try not to pollute, so we don't like throwing anything into the ocean. Yes, we'll run Igor, or we'll communate, what's it called? We'll grind up all leftover foods and pump that into the ocean as burley, but everything else basically we'll bring back with us. So there needs to be a management plan for plastics, cardboard, and what we can and can't ditch at sea. Same with engineering waste. So we'll conduct maintenance, as we said before. So we'll store oily waste and the like. So all that needs to be offloaded when we come to port as well. Lucky last, the return to Australia. So if we've made foreign soil, so we're pulled into a foreign port, the ship loses its coastal status. So if the ship stays at sea and we only have Australian products on board, the ship will stay at coastal status, which means it doesn't need to clear quarantine when it comes back into Australia. But if we embark food or people from a foreign port, the ship goes to what we call international articles, and we have to clear quarantine when we return to Australia, which involves removal of all foreign products. The ship gets inspected to make sure we're not bringing any biohazards back into Australia. I've touched on medevac and compassionate returns to Australia, and while we come back, what we do. So whilst we're away, we traditionally would only do minor level maintenance, stuff that we can either do internally, or we might have an assisted maintenance period at a known, traditionally military facility, where we would have pre-supplied, pre-positioned equipment to do whatever that maintenance activity that we're going to do in that port. So, but traditionally that would not be a great deal. But when we come back to Australia, that's the time where we'll go into docking or do a deeper level maintenance. When we return to Australia, we resupply the whole ship and get ready to leave again. During that time, we try to get people off to quit their leave as well. And then the whole thing's repeated. I think from my experience, the most brutal cycle that I've been was probably on HMAS Darwin, where we spent 14 of 18 months deployed. And only back in Australia for 4 months, or back in home port for 4 months. So having an overseas deployment, that's not the only thing the ship does. So it will have to work itself up to getting to do that. So as a logger, you're supporting all of that activity as well. But that essentially is it. So very happy to take any other questions or any clarifying points that you'd like me to make.
Hey, Sean, Tim here. I've got a question for you. So as you'll be aware, most of my logistics experience has been in the land environment, and generally speaking, the smaller electronic devices. A lot of what I've seen in the maintenance space, and particularly the statistical analysis to work out how many spares you have to deal with, tends to boil down to either generic global fleet averages, or I just say guesswork on the mean time between failure of equipment. Considering how long ships need to be able to operate by themselves, limited space on board, all of that sort of stuff, do you see similar trends with the information available to inform that sparing calculation, or does maybe just need to basically take a gamble and oversupply on the off chance you get it wrong?
I appreciate your point. The Navy doesn't do it that way. So we've had back from the old MICA days, managed codification, I can't remember what it stands for anymore. Navy run a whole bunch of secondary information systems to do analysis on our utilisation. So currently the information system we manage our inventory on for defence is MILIS. MILIS can't deploy and doesn't work at sea and doesn't meet Navy's needs. So Navy's been utilising a different information system that subsequently has to interface into MILIS. But that information system, SLIMS, Ships Logistics Information Management System, that is supported by a whole bunch of secondary configuration management and utilisation software that aids to the calculation of the required spares. So they've broken down all the equipment into lowest level of repairable item. It's augmented by historical usage, and that goes to work out what we call the APL and OAL, so two different types of lists essentially that the ship will embark to reach that algorithm of 95% probability of 90 days. So the work that I was doing on the Defence ERP program was to make sure that that level of functionality is not lost as we migrate our current systems into the Defence ERP system. And I think it has real applicability to deploying forces about trying to work out what your sustainment load or what you should deploy with in order to satisfy your ongoing plan maintenance. So it is there. It's a whole nother art piece basically of different levels of analysis that we've done over all the different parts that go to make up any given component of a weapon system to what we would likely be able to repair at sea. So, obviously we're not going to do circuit card manufacture or something like that at sea. We'd be replacing a whole circuit card or black boxing something. So one whole system out, one whole system in. But that's done well ahead of time, and then it's updated every 3 months by usage. So did that answer your question?
In part, so it answers how things operate once you're up and running and the systems are more well known. I guess when you're right at the start of the process and you're getting your initial set of acquisition data from the contractors, because you can't use real life data until you're actually using it in real life, obviously. Is the starting data set something that, I guess, what is the fidelity of it? How useful is the information you get from contractors? Because I find a lot of the time in land, and again, particularly for those smaller electronic type of things, it's of limited value, but that's obviously far more significant if you've got to be able to operate for, 9 months?
Yep. So, and that 9-month period, that's the deployment, which I can't cycle through the Middle East, but there's, you don't just go on deployment, you've got that whole workup pace beforehand. So you may be spending another, essentially 3 months away before you actually get to that 9-month deployment. But the nub of your question though, it's part of that initial data buy of it's not good enough just to buy the parts. You've got to have all the data, all the metadata that's associated with those parts as well, which includes all the mean time between failures, the limit, the level of which we're going to conduct our own repairs before we have to send it back to the OEM or to the level 3 support to have it fixed, or whether it's disposable. As an acquisition organisation, it's really important to get that right. And yes, so my experience is, I'm not saying I'm jaded, but there's been a bit of both. So some people have done it really, really well, and other OEMs have the proof's not, the evidence of their successful prediction of the failure rates has not been that good. So we've overbought spares on plenty of times. So I think it's a great area for us to improve upon. And as we get to build up that data suite, it is important. So to the point where, like, I'll pick on the FFGs, there's lots of them, or there was lots of them. And so sharing that data across not just the 6 that Australia had, but the 100 that the United States had and the wider fleet was really, really important to then augment or update that usage rates and how we were doing it. Which of course has some challenges as well, because the way we use stuff in Australia, or the climate in Australia, so I particularly refer back to, I'll stick with shipping. the water around Australia is, relatively speaking, is really, really clean, and it's quite cold until you get up to the equator. The water in the Middle East is completely different. It's really dirty and muddy, and it's a lot warmer. So things that work really well normally don't work that well in the Middle East, because things like the reverse osmosis plant, which is the water making machinery, we go through filters at a rate of like 5 times what we would do in Australia because of the quality of the water. And the plants themselves like to work with really cold water, as opposed to they're not that efficient when the water's a lot hotter. So your spare utilisation goes through the roof. So when we first started going to the Middle East more frequently, that was some of the lessons that we learned.
All right, thank you very much.
No worries, Tim.
Any other questions for Sean? Sean, you touched on the environmentals just on that last answer. It's a really good example of the difference in water quality, which I would not have thought about. But I imagine there are other environmentals that put real pressure on the loggy on the ship to be able to make things happen, particularly during RAS. And I'm thinking of sea state or electrical storms, or the fact that 2 ships together makes for a bigger target and more attractive to the enemy, and you're probably limited in speed, or you're probably not defenseless, but you're not as combat ready perhaps when you're doing a RAS than you otherwise might be. Is that true? And is there other sort of environmental factors that can make that can build the challenge for the operational logistician?
Yep, I'll take that question in 2 parts. So yes, whilst ships are razzing, they have to match speed and course. We don't manoeuvre once we're razzing; we're going in a straight line. So traditionally, in an exercise planning scenario, you'd have a RAS box, which is, as you imagine, would be quite a significant body of water, which is where the ships would join up to RAS. So when we set that up, so to obviously reduce the chances of collision with other ships, because when you're razzing, it's very hard to manoeuvre. If you have to break away, that's why the lines that we pass across all have weak links, and literally they will break and fall into the Ogden, which is not an ideal sort of situation. The other part is the environmental part. So I remember one of my greatest challenges was working, I think it was a Talisman Sabre. So we're working inside the Great Barrier Reef National Park, and you just can't put anything in the water. So even the leftover, the scrap food would normally run through Igor to turn it into fish food. We're not allowed to do that either. So because you're interrupting or affecting the food balance in a national park. So you have to keep all that rubbish on board. And when you're feeding 200 people, that adds up a lot, because it's also hot in the Great Barrier Reef. So if you're going to fill up a bin with your scraps, times by, we think about how smelly your bins get at home when you're waiting for the garbo to come around, but times that by 200 people in the tropics, it's, I'm not painting a pretty picture here, and a ship can only have so many bins. So you've got to work out how to maximize that, or how to offload the rubbish, which is, if you're a supply ship, the last thing you want to do is take a bucket load of rubbish off one of the wherries that can't store stuff, and then how to actually manage that. So part of the planning consideration, so think of Talisman Sabre last 19? Yeah, so last year, there were over 20 warships there, each one working inside the national park, each one unable to put food. There was, I think, it was well over 20,000 people at sea, all creating waste. And that's, human waste as well as food waste, as well as packaging, cardboard, plastics. That's a huge chunk of waste. And where's it going to go? So it all has to be held on board, which is a real problem because it just balloons. So what do we do as far as loggies and planners goes? Well, food gets delivered to the ship invariably in cardboard boxes. So we try to take it out of the cardboard boxes before we bring it on board and leave all that ashore. We have plastic, we call them pucks, so we melt plastic down, so it takes up less space. We compact and shred cardboard, so it takes up less space. We smash all glass if we have to take glass on board. Things like when you order meat, we try to order meat without bones. So because the bones can't go through the eagle and they take up more space, they take up more space in, like a chop will take up more space in the freezer. So, so we have to eat fillet steak. Or, I'm joking now. We don't always eat fillet steak and crayfish, but you've got to, when you work out your menus, you've got to think of those things as well, which is just like, that's just crazy. But, the ships, remember I said before, it's all about the weapon system, then it's about the machinery, and then the people come lucky last. So the space for things like storage of waste or it just isn't there. So you've got to look at how to manage that. So we were looking at razzing to offload waste to keep the ship at sea, or you have to go alongside to literally throw it all in a bin. Remember what I was saying about if you had foreign product on board, so your rubbish becomes quarantined waste, so it all has to be burnt, so it can't just go into the the local tip until you've got back to coastal articles. So all that costs. So one little aside, US warships, they use compensating water. So you can imagine fuel tanks, they all go down. If a fuel tank's not full, it creates its own little hazard called free surface effect. So you can imagine water sloshing around inside a tank. It will actually ultimately cause the ship to tip over. So small tanks are better, or baffles inside the tank to break up that surface effect. What the Americans will do, they put seawater in, because fuel floats on seawater, and they take the fuel from the top of the tank in floating rigs. So, but because some of that seawater is going to mix with the fuel, in Australian standards, that's called oily waste. And so when a particular American ship comes along and it's using compensating water, that water has to come off before they can put fuel on. So if they come alongside and do that, it's usually about $2.70 a litre to treat it. So a carrier strike group might come in and offload a couple of million litres of water, which all has to be treated at $2 something a litre. There's a snappy $27 million just in, or $2.7 million just in moving water off a ship. So those numbers get really, really big, really, really quickly, depending on what you're doing. So, but all something to take into consideration when you're doing your planning, and obviously budgets and all that sort of stuff as well.
So I just want to lift it up a level. Mm-hmm. And, they say the military commander that wins is the one with the best logistician. I'm picturing, if you're at sea, I just think there'd be an incredible number of competing requirements that from the birdie that needs a new widget to fix the Romeo to, someone needs to be medevaced off. It's just a constant competition for incoming bulk and outgoing bulk. And I think the people that are pulling those levers could reach right back up into Navy headquarters, I imagine. Is that the case? And in which case, is it true that you've got to be so in step with the commander's intent to be able to know where priorities lie, because there's just not enough resources or space?
Bit of both. So I always say the best thing about being in the Navy and working at sea is you literally are all heading in the same direction. So the command team on a ship is a good working ship. That team's really, really tight, and they're supported by good deputies who are in turn supported by good senior NCOs. Each person has a role to play, and that understanding literally where you're going and what you're trying to achieve is all about that leadership communications piece. And, you know, comes back to your individuals who are better at it than others. So my experience has been the CEOs of the leadership teams that make sure everyone knows what's going on and trusts their troops to the point of, you know, a ship's port visit, or we'll step it up a level. A submarine's port visit details are all secret. So you can't tell your loved ones when you're going to be able to get in touch with them, which port you're going to be in next, because it's all classified. But for the crew's benefit, morale, and understanding, I believe you have to tell them so that they know what you know, as far as their piece of the puzzle that they're specialists in, they can work on that to achieve the same goal as everybody else. So that comes back into that working together. So yeah, the birdies need something, you know, them understanding the process and how that works in order to get it to them is paramount. So, because invariably I send the aircraft off to go fetch it if it's that important. So, or we will reschedule a different port visit, or we'll come in close. So if the aircraft's AOG, we'll come in close, we'll send a boat in, or we'll send a small boat out to meet the ship at sea to effect the transfer, or we'd get another aircraft to bring it in. So invariably, we try not to deploy as a single unit. The whole strength of the Australian Navy is about that mutual operations and about working together, about particularly with other nations, or doing what we call task group work. Trying to cross-level stores or parts between the task group links back to the MLSAs. So if we're, you know, the Romeos are a common aircraft across the Australian and the US fleets, and a couple of other countries also utilise them. Australia's taken the very, very smart stand that we will keep our aircraft at the same configuration standard as the American aircraft, and we'll train our maintainers the same way, so that Australian spinner can spin spanners on an American aircraft and vice versa. So that just steps up that level of interoperability across two navies. The same trickles down with the parts and stuff that we utilise. So if we're at sea with another platform that has the same aircraft, there's a potential chance that they might have that part on board, and we'll get it moved across. And we can do that by any number of different ways.
All right. Thanks, Sean. Are there any other questions before we wrap up?
Hey, Sean, it's Jed here.
Yeah, Jed.
Just with those, when you're talking about exchanging parts from other navies, is that comes under that MLSA agreement?
That's right.
And how does that work? Do we charge them? Do they charge us per interaction?
That's exactly right. So nothing's free. And there's usually there's a periodicity of when we do the accounting. So I know particularly with fuel, it's annually. So they'll work out what we've provided and what they're provided and what we've swapped. And there's a bill later on. So then we do a Department of Finance to Department of Finance type transfer to settle the accounts up at the end.
Oh, right. Okay. And then that's the same story with those, like with the US ships, if they come alongside in Australia, they've got to offload all that oily seawater.
Yep.
We've got to process it according to our standards. And we charge them back.
Normally, so the Americans do exactly the same as what we do. They'll have their equivalent of the SON Pass contract. So they'll have an agent, which is usually paired up with a host officer. So we'd have a senior loggy that will that will host the American ships that come to Australia and help them transit the Australianness of whatever contract they're trying to deal with. So in that particular case, I was talking to the CIs, and they were like astounded at the cost of offloading the oily waste. And it was like, well, if they'd known that beforehand, because it's sorry, I shouldn't say oily waste, it's contaminated water. So it's that, and the level of impurities that's there under the International Pollution Act, it's quite, you're well within your rights to pump that out at sea. But once you're in Australian national waters, our laws are prevalent and our laws are stricter. So they couldn't pump it out into the ocean. So what I suspect is the contractor that they've hired as part of their SOMPAS arrangements, their port services arrangements, has put it into their barge. They then sailed that barge full of contaminated water 12 miles off the coast and then pumped it out into the ocean for $2.70 something a litre. Because that's what I would have done.
Right. And those agents, that when you talk about the agents, that's a commercial organisation that's contracted by the US in Australia in that instance, and they're facilitating exchanges, those kind of customs arrangements, getting people on and off and cargo on and off at port. Is that what their job is?
That's exactly what their job is. And we at Australia do the same thing when we go to, the States or some other country. So we'll have an agent that will invariably be there ahead of time and organise all the bits and pieces that we need for when we get alongside to make, the port visit. Typical port visit would be three to 4 days. So during that time, you've got to get all this stuff done. And remember I was saying about the fuel and how much fuel you want. You could be refueling for 3 days if you weren't at RAS before you got in there. So the engineering staff hate you because you're only there and they're spending the whole time watching fuel tanks and fuel trucks come in and off the ship. So they don't get to go and explore the new country. But yeah, that the agency, which is the A in SONPAS, is the agency agreement. So they will conduct all the foreign currency transactions on your behalf and then send you a bill at the end. So,
right. Are they, one more, sorry. Are those contracts with those agents, are they linked to the MLSAs? Are they part of the same contract suite? So they have obligations to uphold, or they're completely separate?
No, they're separate. So an MLSA is between two nations. The agency stuff is between the agent and the person paying their bills. So an agency, there's a company, Inchcape Shipping is that is a British-based agency that provides that sort of services. And there's a bunch, depending on which section, whereabouts in the world you are, that look after, predominantly commercial shipping. So, thousands and thousands of commercial ships, hundreds of military ships. But they'll look after the military as well. So they're very experienced and set up all these local arrangements. And so they will conduct the business on your behalf until, and then send you a bill for it at the end of the day. So those arrangements, those standing offers, are made well in advance. So I think the current one is a 4-year contract with 2-year extensions, which is under a recruitment or a tender process as we speak.
Mm-hmm.
And all nations, most of the nations that I'm familiar with, that I've worked with, they basically do the same thing. But the MLSAs, country to country, SONPAS or the American or British or the Canadian equivalent is a commercial arrangement between an agent and a navy.
Yeah, right. So it's sort of up to you to make sure that contract with the agent aligns with the agreement you've got with a country. They're not responsible for making sure they don't contravene the MLSA on your behalf by accident, you've got to make sure they're aligned.
Well, the agent doesn't have access to the NLSA.
Yeah,
So
yeah.
That's a nation-to-nation contract,
Yep.
or a nation-to-nation agreement.
Thanks.
No worries. But just on that, the whole the SOMPAS contract. When I was at JOC, I think there was a disaster in Sumatra, and we had to we decided we're going to move some troops into there. I couldn't get any water, and getting the water purification treatment into that country at that time was proving to be very problematic. So I reached back out to my contacts within the SOMPAS contract and said, well, we, the Navy, are fully expected to go to Sumatra. What can you do? Well, it turns out in the center of Sumatra, there's a Coca-Cola factory, and Coca-Cola make the fresh water. Mountain Spring. So it took one phone call, and I think they had like 300 pallets of water delivered within 3 days. So the utilization was phenomenal. So if it's not just a Navy thing, it is a contract that's run by the Navy, but there's no reason why any of the other services couldn't utilize it for a crisis or for their needs when we deploy. Same with the Vittling contract. So for the Middle East, which I helped write, that was actually written for resupplying food to the naval ships. But I know last time I went back there that same company now provides all the food that goes into Afghanistan, Iraq, as well as the UAE for all the land forces that are marked there as well. So, but that started off as a food contract for supplying ships at sea.
All right, brilliant. Well, that's right up to the hour. So thanks very much, Sean. Really appreciate your insight, and particularly for those of us that have lived our lives in the land or space or air domain. It's really,
or South Australia.
It's really interesting to see the operational considerations that are unique to that maritime environment and for logistics. So I'm sure I can speak on behalf of all of us to say we learned a good deal today, which is the whole intent of these sessions. So thank you so much for your time.
Awesome. Thank you, everybody.
Thanks, Sean.
Thanks very much, Sean.